Hello everyone, and I welcome you all to today's video. Today we are going to see the implementation of linear and logistic regression algorithms in Python. We are going to understand these algorithms by solving a assignment question. So in the previous video we saw the difference between logistic and linear regression and how gradient descent in algorithm is used to optimize the parameters of this regression of these algorithms. Now today the question is, write a program in Python to implement logistic and linear regression. For every method, compute and display the implemented models evaluation measures such as accuracy and other values of different evaluation metrics such as confusion matrix, accuracy, precision, recall, F1 score, specificity and loss function, RMSE and R2 score. So let's solve this question. We'll switch to Google Colab to implement the algorithms. So first let's see the linear regression here. For linear regression I'm using California housing data set. So let me introduce you with the data first. So in our data these are the features we have. Out of all these features, the median house value, this feature which I am highlighting right now, is a dependent feature, whereas all other features are independent features. As you can see here, the ocean proximity feature contains string values. To implement the linear regression, we would have to convert this string value to a numeric value. As for implementing of linear regression algorithms, we require data which is purely numerical. So let's see its implementation. First, I've imported all the necessary libraries. I'm using Pandas, NumPy, Math. Then I'm using Scikit-Learn library here. From linear model, I have imported linear regression. From pre-processing, I have imported label encoder. From model selection, I have imported train test split. And from metrics, I have imported two metrics here, which are mean squared error and R2 score. First, I'll read my data into a pandas data frame using the read CSV method. So now, since I already told you that I'll need my data for implementation of regression in pure for implementation of linear regression, I'll require my data in pure numeric form. So I have to convert this string type data which is nearby, and there are also other values for it. As you can see, it has 1 hour less than ocean distance, then it has inland as value. So I'll have to convert this string value into numeric values, for which I'm going to use label encoder. So basically we are encoding this string value to a numeric value. I'm adding here a extra feature to my data set, which is ocean proximity encoded, which contains the encoded values of the ocean proximity data. Here we are using label encoder dot fit transform method. Now since I already have the ocean proximity data in encoded form, I no longer require this feature which contains the values in string form. So I'm going to drop this from my database. Now I'm also showing you that how my database is going to look. My data is going to look after I have encoded the ocean proximity value. So these are the features which are not changed. But here, as you can see, there is no ocean proximity feature right now, but we have ocean proximity encoded feature which contains numerical values. So it for zero tuple, zeroth row, it contains value 3. Earlier it used to contain the value for zeroth row, the ocean proximity value was nearby, which is now encoded to value 3. Similarly, it for the last rows, it contains value 1, which is encoded for any other ocean proximity value. Now, to deal with the missing values from my data, I'm going to impute them with the mean of that respective feature. So that is why I'm using the pandas method fill na, which is fill not available. Now I'm going to divide my data into dependent and independent features. So all the features in my data are independent except the median house value. So X is going to contain all the independent features. Therefore, I have dropped the median house value feature from X, and Y contains only the only dependent variable in this data, which is median house value. So X contains all the independent features and Y would contains the only dependent feature here. Now using train test split, I have split my data into training and testing data. the test size is 0.1, which means 10% of my total data would be used as testing data, and the rest 90% of data would be my training data. Now I have created a linear regression model using the linear regression method. Now I'm going to fit my training data to this linear regression model using LR model dot fit method. Now let's predict the values using this LR model, linear regression model. First, we are going to make predictions for the training data set only. So the y predicted train is going to contain the predictions for the training data set. Now we are going to apply certain metrics on training data set to see the performance of our model, linear regression model. So I'm using mean squared error and R2 score here. Mean squared error is the average of the square of differences between the actual and predicted y values. The root of which is root mean square error, which I have printed here using mat.sqrt function. R2 score is the proportion of variance in the independent data feature, which can be predicted from the independent data. Then I have implemented the same metrics on the testing data, the results of which now you can see. The training root mean square error is 69270, whereas the same for testing data is 73644, and you can also see the R2 score values. So this was the implementation of linear regression in Python. Now let's move on and let's see the implementation of logistic regression. So for logistic regression, I'm using here PIMA diabetes dataset. Let me show you dataset once again. It contains several features, and out of all these features, the outcome feature is here is an dependent feature, whereas all other features are independent. So this is a database for a classification problem, and since we know that logistic regression is used for classification problems, we are using this dataset. Again, I have first imported all the required libraries here, which are Pandas from model selection, train test split to split data into training and testing data sets. Then I have from linear model the logistic regression, and then there are several metrics which we are going to use to measure the performance of our model. Again, like in linear regression, I first read the data into a Pandas data frame using the read CSV function method. Then, since this data does not require any kind of pre-processing or imputations, I am directly going to divide my data into its dependent and independent features. So, like always, X is going to contain all the independent features. That is why I have dropped the outcome, and Y would contain the only independent feature, with the only dependent feature, which is outcome. Now I'm going to split my data into training testing data set, for which I've used the train test split method. The test size for this time I have chosen 0.2, which means 20% of my total data would be used as testing data, while other 80% would be used for training data. Now we are going to implement the logistic regression. We are going to implement the logistic regression here. So I have constructed a logistic regression model, and I have given it the training data, my training data. So I have fit the training data to the logistic regression. Again, we are going to make certain predictions first for the training data set, and then later for the testing data. So the y train pred contains the predictions made by the model for the training data. Now we are looking at the metrics for training data. First is the log loss, which is also known as logarithmic loss. The log loss function is also the cost function for logistic regression. Then I have confusion matrix, which gives me the true positive, true negatives, false positive, and false negative. Accuracy is the ratio of total correct predictions upon total number of predictions. Precision is the ratio of true positives upon total predicted positives. Recall is the recall is the ratio of true positives upon total actual positives. F1 score is calculated as 2 into precision into recall divided by precision plus recall. Specificity is calculated as true negatives divided by total actual negatives. So these are metrics which I have used on training data, and same metrics I have implemented on training data. So the y-test spread contains the predictions done by model on testing data, and we have calculated the metrics for the testing data as well. Now let's see what our data, what our results are. So first, I have the shape of data here before splitting it into training and testing. Which is the outcome of this statement. So here I am printing the shape of my data, which is it contains 768 rows and 9 columns. Then after splitting into training and testing data, since I told you that there are the 20% of my data would be used as testing data, so 154 rows are randomly selected for testing data, and 614 rows are used for training the data. Now here are the values which are for several metrics which we have used in our program. This is the value for the train loss, and we can also see the corresponding value for the test loss, which are the values of given by the log loss function. Then this matrix here represents the confusion matrix. The values in diagonal are true positive and true negative, and the other diagonal values show the false positive and false negative values. Further, you can see the accuracy, precision, recall, F1 score, and other metrics. So this was the implementation of logistic regression in Python. So we have successfully implemented both the algorithms in Python. I hope you understood this video. If you have certain questions, you can drop them in the comment section. I'll surely answer them. I hope you like this video. If you gained some good insights from this video, consider liking this video and subscribing to my channel. I'll see you in next video. Thank you.